Okay, so here's a proposition that is pretty interesting to prove using the induction method. So it says for any integer n greater than or equal to 8, if you had n cents, you can basically construct them using 3-cent and 5-cent coins. So pause the video for a second and see if you can try this out for yourself and, restart in a few seconds. So hopefully you did. And so again, the proof is going to be a proof by induction. So I'm going to start by writing that down. And I'm going to begin by first saying let n be the integer that we're talking about. And the restriction here is that it has to be greater than or equal to 8. And as usual, the very first step you want to do is the base case. That's always going to be the first step, and you're going to need to label it. And then in this particular problem, n is supposed to be greater than or equal to 8. Since n is supposed to be greater than or equal to 8, we're going to begin our base step with 8. So what you're trying to do is basically see if this statement holds for n equal to 8. And it does, because 8 would be basically a 3-cent coin plus a 5-cent coin, if we had a 3-cent coin, basically. So the theorem is actually true, and we're basically done with the base case. So now the inductive hypothesis. And in the inductive hypothesis, we're going to basically suppose that the theorem is true for a random n. So suppose that the theorem holds, the proposition is true for some n equal to some random number k, where k is an integer. And what we want to do is we want to show that the theorem actually holds for the next case. So we want to show that the proposition is true for the next guy, k plus 1, basically. And pause the video again and see if you can try to prove that. Okay, think about it for a minute and see what you can do. Okay, so hopefully you took some time to think about this step and how you would go about proving the inductive hypothesis. But the idea of the proof is this. If your n, let's say, involves some coins that we don't know what they are, but let's say you have a 5-cent coin, and we can make that assumption maybe, and we'll take a look at the other case. If there's a 5-cent coin, all you have to do is erase it or get rid of it and replace it with pretty much the same stuff, but instead of a 5-cent coin, we could replace it with 2 3-cent coins. So that one becomes 2 3-cent coins, and therefore now you have added 1 to the number, and the theorem is now true, because all you have to do is bring all these coins down, whatever they are, and just basically add the 2 3-cent coins at the end. Now, what if your number did not have the 5? So what if your number that you began with has only 3-cent coins? Well, remember, the n has to be bigger than 8, so it cannot have 2 3-cent coins. The minimum it's going to have is 3 3-cent coins, because 8 is already 3 and 5, we've proven that, and 9 would be 3 3 3. So in this case, what you would have to do to get to the n plus 1 is actually erase the 3 3-cent coins and replace them with 2 5-cent coins. So this is what the book is basically trying to tell you to do. If you read this already, that's basically the idea of the proof. Okay, so I'm gonna go ahead and write this down and kind of make it my own language, but that's basically the idea. So there we go. I'm gonna say case number 1. If the coin, or if the number has a 5-cent coin, then what we do is we remove the 5-cent coin and replace it with 2 of the 3s. And thus we go from n to n plus 1, and we're pretty much finished with this case number 1. Okay, so that's basically the end of that. I'm going to go ahead and squeeze it a little bit so that fits. And now let's look at case number 2. Case number 2, well, what if the n did not have a 5-cent coin? What if our n has no 5-cent coins? Then in this case, the n should have basically 3 of the 3 cent coins. So in this particular example, I'm surrounding the coin number with the circle. And so in this case, this is a legit assumption because remember the n is supposed to be bigger than or equal to 8. 8 is 3 and 5, but 9 is already 3, 3, 3. So that works. We will have at least 3 3-cent coins no matter what. And so what we do in this case is remove the 3 3-cent coins and replace them with 2 of the 5-cent coins. And so therefore our n is going to be basically increasing by 1 because you took out 9 but you added basically 10. So yep, your n has grown by 1, and that's what you wanted to do in the first place. So at this point the theorem is basically finished, QED, and that's the end. So I'll see you in the next video.